Good afternoon, everyone. This is Gilla Lovera with Moldex 3D. Today we have our partner reseller, Dr. John Perdiculias, who will be presenting injection molding screw analysis and optimization. He's a professional engineer in Ontario, Canada. He earned a bachelor's in chemical engineering and a master's in engineering from McMaster University in Hamilton, Ontario, as well as PhD from the University of Waterloo. He has over 35 years of experience in the plastic industry, specializing in equipment engineering and process optimization. He's a co-founder of CompuPlast International Inc., which has provided CAE software and services to the plastic processing industry since 1990. John, over to you.
Thank you very much.
Sorry about that. Just quickly before we start, I want to also remind our audience to keep their microphone muted. And also, if they have any questions, please use the chat section. And at the end, we will send you a survey. If you fill out, then later on, we will also send you the recording of this session. Okay, now, John.
Thank you very much for the intro, Scylla, and thank you all for participating in the event. Let me just share my screen. Presentation over here. So, as Scylla mentioned, CompuPlast is a provider of CAE software and services for the past 30 years, but we had mainly focused on extrusion and extrusion simulation software. And we realized that a lot of injection molding companies didn't realize that they had a little extruder on their machine, which is basically a screw and a barrel that melts the polymer and prepares it to be injected into the molds. And it's basically a similar process for melting. And so we decided to apply our extruder module, which simulates the conveying and melting of pellets inside a barrel with a screw. And I wanted to demonstrate how that part of the process can be very significant with respect to the quality of the products that you make, not only in extrusion, but also injection molding. And it has its particular little quirks based on the screw design and the polymer rheology that we have. So just to save a little bandwidth, I'm going to turn off my camera here.